Now we have Mr. Zhang Wang, who will be talking on Virtuo, Vhost, status quo, and near-term plan. So put our hands together for Mr. Zhang Wang.
Okay. Now it's the second time in a single day for me, so I won't be nervous this time. Okay, in this session, I'm gonna talk about the virtual and Vhost status and some near-term plans, so what we can expect in the near future in DPDK. And so I just want to ask first, how many of you knows about virtual and Vhost? Please raise. Oh, that's quite a lot. And how many of you knows how it works, like use cases? Okay, that's great. Seems I've come to the right place, and also hopefully after this session you can learn know a little bit more about Virtuo and help us to improve it. Right, here's the agenda. So Virtuo, I can give a brief introduction first. Virtuo is a virtual I/O interface for multiple hypervisors. And it has been first introduced in 2008. And over the 10 years, it has been kind of the de facto interface in PRC. So Virtuo is keep evolving recently. It's not, right now it can for VMs and it can for containers. And also it can, it's been widely used for virtual switching, and also it can be used for acceleration, just like we mentioned in FPGA, that part. And also the spec is also evolving because previously Virtuo has its written out and two spec, right? 0.95 and 1.0. Right now there's 1.1 spec that's expected to be published in recent times. And also Virtuo can run, previously it's for cloud usage, right? And right now I think Virtuo is also evolved can be used for NFV use cases. So here's agenda: performance, efficiency, scalability. This stuff, we're gonna talk about them one by one. So first is RAIN layout 1.1. It's kind of a huge milestone for Virtuo spec, because in previous Virtuo, no matter 0.95 or 1.0, the RAIN out is the same, right? It has three RAINs. From software point of view, it's very flexible. It can support a lot of operations. But from performance point of view, it might not be that efficient, especially when we talk about accelerations. So it should be more hardware friendly. And that's why Virtuo 1.1 came to the stage. So the solution is, of course, we evolve the RAIN layout, and the discussion has been in the community for quite some time, and DPDK and Intel, we see a lot of discussion, and we also provide, some suggestions and recommendations. And right now, the spec is expected to be free in March. Hopefully, it can meet the schedule. And upstream plan, DPDK will try to upstream this support of Virtuo 1.1 in 1805, and we'll try to meet the schedule. And also, there's going to be kernel and QEMU patch out there. And we can see from on the right-hand side the performance. Right now, it's the initial performance gain for smaller packet is about 12% percentage. You can see the numbers in the mail thread where here in the reference. But there's big room for optimization because this is the initial code base, and without any aggressive optimization. Right. Okay. The second one is DQ zero copy. DPDK has support DQ zero copy for maybe, I don't remember which release, but I will definitely support it. And currently there's some gaps, right? The reason why we want to do zero copy is that, especially for large packet, the memory copy takes a lot of cycles. And So we want to eliminate at least one copy when we do the virtual switching between like inter VMs or from VM to NIC. And the gap I think it's kind of hard to use without any base known configuration here. So I think we should provide some. So here we list two of them, and which is the main constraint, the main guideline to use to enable the DQ zero copy. One is that because if you use zero copy, it's likely that when you're trying to send out some packet, and the packet will be held in the virtual switch, and you don't know when the packet will be sent out actually. So the descriptor will actually be occupied until the packet is being sent out. So in that case, to avoid the device just hang there, we can we can just use larger ring size. Like for each TXQ, there's going to be a free threshold, which means the descriptor we will free the threshold the descriptor when it reaches this threshold, and it multiplies with the TXQ number. So basically, the virtual ring size should be larger than this. And then, because their copy is for performance, so we prefer to use huge pages to further boost performance. So we prefer 1 gigabyte because in that case the memory translation is going to be, because you're going to for NIC, you have to use real hardware, what do we call it, the hardware address, right? In that case, DPDK will do the translation, and if you use 2 megabytes of huge page, it's going to be a lot of lookups, and performance might not be that good. And another action to do is in DPDK we have to lock the guest memory to avoid the DMA read fault, and the plan is to fix that in 1805 release. Okay. Right now, this is a Vhost interrupt. In DPDK currently we don't support that, and why it's important. We always say that DPDK want to be green, right? It's not a joke actually. Last time when Thomas said that, Thomas said in the Ireland summit, every people applause because DPDK need to be green. And so interrupt is one approach for that. And it's not just for power efficiency, but also I think interrupt can also be very critical for performance, because we really observed that in real deployment, in real cloud deployment, we see in one server over 250 VMs being deployed. And in that case, for instance, if that, we know that not all the VMs will be active, just at least in network. So if only 10% of the VMs are active in network, and 9% of them are idle, in that case, the empty polling of DPDK will cause a lot of cycles simply being wasted to do the polling. So in that case, if we have interrupt mode supported, we can have better mechanism to both be power efficient, but also be performance. There can be performance improvement also. So the plan is we will support the Vhost interrupt in 1805 also. Okay, memory parallocate. This one is actually a good feature of virtual switch, because if you use accelerators, in that case, you use DMA, and all the memory you need to pin the guest memory. You need to pin to hardware address, and which means all the memory must be pinned in the beginning of the initialization, and that may not be that efficient because that memory might never be used. And but you cannot, you have to commit it in the beginning. So for virtual switch, this is not a mandatory option, and So we have to, we can leverage this good thing about being virtual switch is that there are three, it's kind of like BKC, there's not much development effort, but there is some change needed in the DPDK Vhost user library, which is to enable no mandatory memory population in the host user. And after that, in QEMU command line, we also need to specify that we don't need to allocate all the memories when we start the QEMU. And finally, in applications like virtual switch, we just don't use mlock-o, that kind of operations, unless it's really needed. So in that case, I think it's going to be a kind of trade-off, right? It's like for instance, we have a certain amount of memory, and we want to put as many VMs as possible, but it cannot be like this kind of linear scaling forever. So it's kind of trade-off. With this method, we can enable this, avoid memory paralog mechanism, but it actually depends on the workload and deployment to decide how many VMs can be started in a single server. Right, then we will talk about the Vhost PCI and the virtual Vhost user. The reason for Vhost PCI is to accelerate the inter-VM communication. And like we know that in the virtual switch use case right now, if for west-east traffic, like if VM want to send the packet to another VM, it has to go through the virtual switch. And it's just, you're doing 2 times the overhead for one transaction. That's not very efficient. And zero copy can help here, but also zero copy, it's also not, I mean, zero copy can help, but zero copy, there has some limitations. So Vhost PCI is invented to solve this issue. And instead of centralized virtual switch, we can use peer-to-peer channel to do the inter-VM communication. So in that case, basically this can boost performance, but because it's also virtual and the Vhost interface, the absolute performance is, I mean, if you provide enough resources, the performance should be the same, but it can save cores. Like you don't need the virtual switch cores to actually do the memory, do the transaction for you. So it has better resource efficiency and also better scalability because you basically remove the virtual switch in between, so it won't be the bottleneck. And also latency-wise, it can also, right? The path is short, so the latency is also will be improved. And right now we have the RFC patch out there. Both QEMU and DPDK patch is available. So if you want to do some POCs with this patch to showcase whether this method meets your requirement, I think it's already there for you to use. But there's some change in the community that Vhost PCI, after discussion, Steven in Red Hat actually come up with a kind of better model. It's basically the same thing, but wrapped in different, different ways, like the virtual Vhost user. It's a different name and some slight change in the device model, but it can provide the same level of performance. So all these discussions and some POC code is out there in the link provided, so you can go take a look. Right, and this one is a kind of like a big one, where we talk about FPGA acceleration, and this is how virtual and Vhost answer to the new acceleration. And this one has actually been presented several times before, like in 2017. Steve has presented this in the PRC DPDK Summit and also in KVM forum, I guess, last year. This is how Virtual really take step in the facing area, because when we talk about high performance, we think of SROV, right? The SROV will provide very good performance, but when we talk about cloud friendly, we excuse me, we will think about the Virtual because we can do lab migration. It's also it's already supported in a lot of VMs. And can we mix them together? Well, the answer is yes. We can just do SRV for the data path and for the control path, the configuration space, like that kind of stuff. We can do para-virtualization, just leverage the virtual interface. So this solution will provide just both cloud friendly and high performance for virtual interface. And the target, we will upstream, we're trying to upstream this VDPA framework in 1805, and currently it's V2. And so I hope you guys can take a look, and it will be very helpful to us to, whether you like it or not, just provide your comments. And then is cross-backend lab migration. Well, this is a real customer requirement that like in PRC, people are saying that, DPDK is good, but always DPDK is very good, and how can we use it? Because we already have our virtual machines both running in kernel OS, right? We want to do lab migration. We don't want to shut down all of them. And so we need to do lab migration. So to enable that, we need the three areas that we need to be addressed. First is the feature parity. This is already done in 1802 release. We fixed a lot of feature gap between DPDK Vhost and the kernel Vhost.net. And also, the command line, maybe it's too small for you to see, but you can always see the slides in the website that when we started QEMU, the memory tab need to be consistent, like we should use object to start the QEMU to ensure that the kernel, we can do the lab migration smoothly. And finally, if from orchestration level, like OpenStack and Libvirt, well, because basically there are two kinds of backend, and the command line is different, so from orchestration level, we also need to adopt those differences. And with that, we solved this lab migration issue. And then virtual-user server mode. First, I want to explain what is virtual-user, right? We said that virtual can be used for container too, and virtual-user is the interface for that. Basically, it removes the QEMU from the picture, and then it implements its own adapter, so virtual can be running in containers. And the motivation is that for QEMU, we know the reconnect is very important for our cloud customers. Like for instance, if the virtual switch need to reboot for some hard upgrade, then we need the just the connection of the guest can connect to the virtual switch after the upgrade, and so we need to use the kind of like this virtual the guest to create a socket, and then so if the VNF or the guest reboot, and then in the Vhost side, Vhost have a thread to keep trying to do kind of reconnect. So the reconnect is solved both direction in this way. But if you use Vhost to create the socket, then QEMU does not have the method mechanism to do the reconnect, so it will fail. And this is already working in QEMU case, but for virtual-user, it's kind of like a missing feature there. We're just trying to fix this gap and make the reconnection work for both VMs and containers. And the target is 1805. Okay. And finally, the runtime memory provisioning. This feature, it's kind of like a fix, and also we can call it a new feature. What we're trying to solve here is that when we start a VM, that we can start with a certain amount of memory, and after that, if there's more requests, like I want to add more memory to this virtual machine, then we can do dynamic add of the memory at runtime. But in DPDK, we host backend, because there's no variant protection previously, then when we unmap those memory regions, the other threads of the application might be accessing these variants, and it will be segment fault. So now it has been fixed in 1802. So right now, it's because it can support runtime memory provisioning. And other than this, it has it actually fixed more problems, but this is one useful use case. Okay, so that's all of the updates. So any questions?
So you mentioned that live migration is not friendly in case of Vhost user. So, and in case of Vhost user it is friendly, and in case of kernel it is not friendly. So why it is like that?
Could you?
The VM live migration is not friendly in case of kernel, whereas it is friendly in case of Vhost user. So that's what you mentioned. I just wanted to know why it is friendly in case of Vhost user space.
Sorry, I didn't catch your question. Could you repeat that?
The VM live migration
is
friendly in case of Vhost user.
Do you mean SRIOV versus Vhost?
Oh, you mean SRV versus Vhost?
No, in other words,
so
you mentioned about VM live migration, right, in one of the slides.
This slide?
No. Yeah, that's correct. The other one.
This one?
Yes.
Okay, yeah.
So the live migration is unfriendly in case of SRIOV.
SRV, what
that
we
means
mean?
In kernel.
Yeah, what I mean is for SRV, if it's a vendor specific device, like we have all this stuff, it's from one vendor. I think that's doable. But if it's open source, like you're doing KVM, QEMU, other stuff, that's going to be hard to do. So that's what we say. The SRV is not live migration friendly.
So the other question is, since the live migration involves transferring the GBs of data, right? So is there any plan of using the compressing the data and transferring?
Yeah.
So is there any plan for that?
You mean how live migration works, or?
I mean, basically, in case of whatever, let us say in user space, right? DPDK, with the DPDK, so are you planning to provide any hooks for compressing the data first, then transferring to the other VM?
Oh, you mean trying to improve the process of live migration, right?
Yes, because it includes transferring a lot of data, right?
Okay, yeah, that's currently, because that process is being managed by QEMU, and yeah, I think it's a good area to be explored.
Because you mentioned it as a low performance, that's why I wanted to mention that.
Yeah, we know that live migration does have some, especially when we have high-speed connection, right? Live migration current way is going to be painful because you have the very frequent change of update of your memory. In that case, it's going to be very painful. So, well, you mentioned that, well, compression solve this problem.
Okay.
Right? Yeah, so I guess that with something we can look at. Yeah. Thanks.
We'll take one last question, please.
I have a question with respect to zero copy. So in case of zero copy transmit, virtual machine's memory is being used. So when IOMMU is also enabled for DPDK, does this also work? when IOMMU is enabled for DPDK,
Yeah.
does zero copy work because it is the virtual machine's memory for
Ver-
transmit?
Okay, okay. VMMU is just being supported in DPDK, right? Okay. And yeah, I think for that one we can, yeah, maybe we can discuss offline for this. Well, because basically we need to absolutely make sure it works. And I don't know if we have done that kind of test before.
Okay, sure. Yeah, another short query is that with peer-to-peer virtual machine communication, how is the memory shared via QEMU?
Oh yeah, yeah.
Yeah, in this, yeah.
This one, right?
Yeah.
Yeah. So basically, it's still from the guest to share its memory to another one. So instead of share it to the virtual switch, so the vhost part will be running on another virtual machine. So it's basically still the same mechanism.
Yes, but each virtual machine has separate memory address space, right?
Yeah.
So how it becomes accessible to other virtual machines?
So it's kind of it's the same like what we're doing with vhost. You share memory, and the memory region can be shared to another process. It's kind of like the same mechanism.
Okay, thank you.
Okay, thanks.
Thank you so much, Mr. Wang. It was a pleasure having you. So Mr. Wang flew from China just for this event exclusively, and we extend our thank you, Mr. Wang. So he's flying back tonight as well.